multiplying complex numbers isn't bad either. Let's take the numbers from the last video. I think they were 1 minus 2i and 3 plus 4i. Now I'm going to multiply them together, and what would you do? Well, the natural thing would appear to use distribution to multiply these out. What's often called the FOIL method, so-called FOIL method. So if I FOIL this, I get 1 times 3 is 3. 1 times 4i is plus 4i. Negative 2i times 3 is minus 6i. And then negative 2i times 4i is minus 8i squared. So, very ordinary polynomial multiplication using these numbers. Now, we can do some combining, of course. These will combine. But what about this term here? Well, the I squared, remember, is the same as negative 1. So this becomes 3. And then here, these combine. 4i minus 6i is minus 2i. And then here, I have negative 1 times negative 8 is positive 8. And so these end up with, those combined, we have 11 minus 2i. All right, so we started with a multiplication of two complex numbers. We ended up with a complex number. And that's the way it goes. Multiply two complex numbers, you get a complex number. And so it's very straightforward there. Before we move on, I'd like to do something a little extra that I don't believe I covered in my book. And it's related to multiplication. Let's look at powers of I. And so, because there's really not much else to say about this subject. You just have to go out and practice it. But if you're multiplying more than two complex numbers together, then you could end up with higher powers of I. And so, if we look at this and say, well, okay, now I to the first power is I squared is negative 1. What would I cubed be? Well, I cubed would be I squared times I. I squared times I would be negative 1 times I. It would be negative I. And if I went one more power up, I to the fourth would be I squared times I squared, which is negative 1 times negative 1 equals to positive 1. And so starting here, I go first, second, third, fourth powers. I have I, negative 1, negative I, 1. And now if we go to the fifth power, this will be I times I to the fourth, which is I. I to the sixth will be I squared times I to the fourth. That's negative 1. And you'll see this pattern cycle over again. It'll recycle itself. So these four numbers keep turning over cyclically, and which makes it kind of interesting. Now in higher algebra, abstract algebra, we say that this forms a mathematical group or an algebraic group. And a group is an algebraic system. It's more primitive than what you're accustomed to in terms of numbers of rules available to you. A group has only one operation to it. It would be like having only, say, multiplication instead of both adding and multiplication. And so the letter I under multiplication forms a closed algebraic system with only four numbers to it. And again, they cycle over. I use that term because mathematicians call it a cyclic group. You can actually use this to represent something like a square. So here I've got a square, and I'm going to label the sides in order. 1, I, negative 1, negative I. And if I rotate this square by 90 degrees, counterclockwise, if I just spin it this way, then 1 turns into I turns into negative 1, and so forth. And so you could look at each rotation of the square by 90 degrees as multiplying these numbers by a power of I. And so it's possible to link this pattern, this recurring pattern, this cycle, to somehow, some kind of way of enumerating spinning a square by 90-degree increments. And so the power of I, for example, I to the 6th would be the same as taking 1 and spinning it 6 times through 90 degrees. So 1, 2, 3, 4, 5, 6. I to the 6th is negative 1. How about I to the 11th power? What would that be? All right, if I start with 1, and I go 11 times, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I didn't do that right. I start here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would get me to negative I. So there's some kind of neat ways to look at these. That I thought I would throw this in as an extra. This is doesn't even begin to scratch the surface of these things called groups. This actually forms an advanced branch of abstract algebra called group theory, and people study that at very deep levels, and it's kind of a favorite subject of mine. But okay, so we've talked about adding, subtracting, and multiplying complex numbers, and getting back down to earth here. Dividing complex numbers is next, and that's the most complicated, as you might expect, of the 4 basic operations.